Industrial safety systems are critical in ensuring the well-being of workers and the smooth operation of processes. While every industrial system will have different safety needs and should always be checked by a professional, getting your safety system set up with a good safety system is not very hard. My name is Jean Lim. I'm a product specialist at EamdM, and in this video, I'm going to show you how you can set up a basic safety system that meets your needs with a few key components, using a SICK Flexi Compact safety controller, some safety devices, and 6 Safety Designer software. The base foundation of a safety system is the controller. For this setup, we'll be using the SICK Flexi Compact. This FLX200 has everything you need, with 32 I/O within a 46mm wide housing. The FLX200 has a Modbus interface for easy integration with an HMI or PLC also. The modularity of this CPU lets you expand further, with extra I/O modules, like this guy, or gateway modules, like this guy, to communicate non-safe diagnostic data. This modularity guarantees future-proofing, allowing the use of flexible solutions with modular hardware. The Flexi Compact is also software programmable, configured using 6 intuitive Safety Designer configuration software. With simple block function programming, you can get yourself a safety system quickly, while network functionality allows you to send diagnostic data where you need it to go. Now let's go ahead and see how easy it is to use Safety Designer to help program our safety system. Start a new project. And here we go. So Safety Designer's user interface is designed for intuitive operation. So from here you have your starting page, and you go all the way to the right. And then per page you go from whatever's at the top down to the bottom. So it has this left to right, top to bottom design to configure all the parts in your system. So start here with this new project. Let's go ahead and we can go ahead and add information like who made the safety project. Let's just put my name on there. The name of this project, we can call it sample safety system, and a description of the safety designer project. So we can call it controller with safety devices. You can do other things here on the setting page, such as deal with your network settings, your network router settings, any time synchronization settings, and also how to do your data recording settings right here. So that's your settings page. So now you'll go to the next page, which is your configuration page. And this page is where we decide what needs to be configured for this safety project. From the right, there are a list of products that are configured with Safety Designer. As you can see, not only do we have our safety controller right here, we also have things like our MicroScan 3 and our Outdoor Scan 3 and our NanoScan 3, our safety rated LiDAR systems. We have our safety encoders right here as well. Let's go ahead and start with our safety controller right here. We are looking to build a safety system that uses digital outputs thanks to a RFID sensor, RFID safety switch. We might also need some mechanical contacts with our magnetic safety switch. So something like the Flexi Compact would be really good, because then in one module, you can work with both OSSD and EMSS type systems. I have here a CPU C200. Let's go ahead and just click on that, and then we'll hit apply. So this next page over here is the controller overview page. This has all the information on the specific Flexi Compact. Once we save this, this project name should be added to here. So the next page over is our configuration page. This is where we can go ahead and include all our safety elements into our Flexi Compact. We can even add in any extra modules that you need. For example, if you need a digital output module or a digital input module, you can add that on there. You can even add a Profinet IO gateway. This is a really good way for you to start building your safety controller, depending on what you need. Let's go ahead and delete those, because for this application, we really just need the original module. Here are our elements page. Here we have a variety of sensor inputs right here, like our control devices, our light curtains, our non-contact switches, things like that. We also have output types such as, a motor contactor, lamps, valves. You can even include little graphics that make things a little bit more that makes things a little bit more clear, such as a lamp right here, or a motor or a robot. And then we have all these input tabs. All we really need to do is drag and drop into our system, okay, to include it into our CPU. This easy drag and drop system really makes a quick physical visual on how your system could be wired. It creates a quick visual on what exactly you might need if you need extra I/O. If not, this is a really incredible way for you to even start building what you need without even having any equipment. So based on our application, we're going to need an RE13 magnetic switch. And as you can see, that magnetic switch already is going to require some outputs, and that output is already tacked on right there. We are going to need an SDR1 RFID switch. We do have a light curtain on here, so we're going to attach the DTEC 4. And we even have an e-stop. We have a dual channel e-stop. I currently hold an ES11 right here, so we'll go ahead and drop that on there. And then for our outputs, we want to get a couple lamps in just to make sure that we have some warning lights, showcase whether we need to reset or restart our system. We have the motor that our system is set up with. And then of course, we're going to need some inputs for these lights. So let's go ahead and go back to our inputs. Call them our free contacts. They even have a contact here that already calls start and reset. We can go ahead and just tack that on there. And just by dragging and dropping, you already created a good visual on how exactly you need to connect your safety devices into your controller. So the next page over is our logic editor page. This is where actual safety programming is going to happen. So what's really nice is Safety Designer uses block function programming to build a safety program. So let's go ahead and start with our inputs right here. We have our non-contact switches, we have our DTEC 4, and we have our e-stop. And what we want to make sure is that anytime these systems turn off or release an output, our program, our system stops. So at any point in time, any of these systems is off, we'll get that going. So what we'll use is this and function block to simulate that any event that one this is off, the system shuts down. This and block right here starts out with 2 input connection points. You can just add a couple more, and then we can hit OK. So now you have 4 input connection points for you to add in all your inputs. So now in the event one of these safety devices gets triggered, we need to let the user know that the system must be reset. So we have some basic applications here that you can add, like our reset and our restart. Go ahead and add a reset block. We can also go ahead and add a restart block. And within each block, we need to make sure we have the correct inputs. So we have our reset input right here. We'll have our start input right here with our restart. We also have some specific outputs, like one lamp for a reset and another lamp. Mm, Let's go back from the lamps. And here in our outputs, we have our two lamps. We have one for a reset and we have one for a restart. And finally, we'll be connecting this to a motor to our system to ensure that that motor will start working once we go through all these steps. We have these two lamps. They can be a little confusing, but thankfully, if you go back to our configuration, we can just rename it. We can tag this our reset lamp. We can tag our other one our restart lamp. Now, if we go back to our logic editor, we have them lined up. We have them renamed, which is great. So now we need to go ahead and connect all these systems into our reset. We have our input, and then we have our lamp. So when a restart is required, a lamp will signal. And then after that, and once we're good to reset, we'd be good to start. So we have our start enabled. We'll have a lamp available when or we can say that we need to do a restart. And then now we have our motor, our output motor being enabled once all this is good to go. So that's our logic for this system. And now all we need to do is test it out and see if it works. The logic editor offers a live simulation test to ensure that everything operates correctly. You can click on the simulation button right here to start it. So you start your simulation mode. Then you can hit the play button to start simulation of your program. So the simulation starts with your inputs currently not powered to monitor your devices. So let's go ahead and lock the system to safe state by powering these devices. So that's our magnetic read switch turning on, our RFID switch turning on. As we keep clicking, all these things turn on. We have our light current turning on and our e-stop turning on. And as you see, now that all these are all energized and protecting our system, this goes straight to our reset lamp, and our reset lamp is now flashing. Here, we hit the reset button and release it to simulate pressing the reset button. And now once you've reset the system, we're back to starting the system all over again. Now you hit start, release it to simulate pressing the start button, and now our motor is turned on. So we just simulated a reset/restart of our compactor or of our system with our safety devices on and operating. Now, if we trigger our safety device by turning one of our inputs off, let's say we broke we broke a beam on the light curtain. Now our motor stopped. We can diagnose the issue. Oh, someone broke the light curtain. No, now it's not broken. The system's on, and now we're back to doing our restart for the system. Go ahead and press that reset button. Now let's press that start button, and now our motor is back going. So with this live simulation, now we're showing the safety system operating as intended. If any of these safety systems, if any of these protective devices gets triggered, your system stops. And that's what we want to do. And there you go. We've just created a safety logic program for your system. After that, on your next page, Your safety project builds a report outlining information on the project, as well as building a bill of materials for your system. So right now, these are pretty generic. These are pretty generic bill of materials. We didn't really specifically include what type of system that we had on there, but this just goes to show how what exactly is is part of the safety system. It even shows in I/O elements, logic connections, what function blocks are used, any diagnostics that might happen at the end of it. Go ahead and save this project with the save button. You can name it our sample safety system, save it wherever would be useful. I just have it here on my desktop. And there you go. You can close this tab, that project tab. And if you go back to Safety Designer, you can pull up that new project that you just made. You hit Open Project, saved as our sample safety system. Now we're back at it. Now let's transfer this program into your controller. Let's go ahead and turn on the controller and connect it to your laptop. And you'll need a micro USB controller to connect into the Flexi Compact. So here is a quick show of a Flexi Compact with a verified and working safety program installed. On the Flexi Compact right here, you have a yellow status indicator light at the top. We call that the CP light. That indicates configuration transferred to the Flexi Compact has been verified. It would be blinking yellow if the configuration wasn't verified and it was only transferred in for testing. So in the event this Flexi Compact is shut off or disconnected from Safety Designer, an unverified safety program would not be saved into the Flexi Compact. The rest of the Flexi Compact indication lights are in green. The power indicator light on the top right is a solid green, meaning an application is running and working correctly. Input lights in the center of all those lights are green, meaning the inputs that we have, or in our case, safety devices that we connected to the controller, are on and their input is active. The test output on the bottom is green, meaning our output is on. During our walkthrough, this would have been something like our trash compactor's motor. It could also be an indication light. It could also be, the connection directly to your machine system. So then, as we zoom out, you would see that we have safety devices set up on this frame. We have a light curtain here in the center and an RFID safety switch on each side of the system. We've set up this program very similarly to our safety program walkthrough, where in any event any of these safety devices are tampered with, the system will shut off the output. So as you can see here, if I impinge on the safety system, you'll notice that the output light at the bottom turns off. Same if I open this door on the side here. As you can see, the output shuts off. Anytime any of these safety devices are tampered with, their corresponding input light switches off, and the bottom output light switches off as well, meaning the output has been cut from our power. Once the safety devices are set back to a safe state, our bottom output light switches back on, meaning the output is now powered up again. And just like that, you now have a system that would shut down in the event any of these safety devices are set off. You could introduce a system like this to any automated machine that you have quickly and easily with just the Flexi Compact and some safety devices. And that would immediately make it safe for the process and for the people operating. Thanks for your time, and I hope you keep watching most of EamdM's videos. Thank you.